Hello all. Before moving on to our main topic, UV visible spectroscopy, let's take a look at what is spectroscopy. Spectroscopy is the study of interaction of electromagnetic radiation with matter. The nature of the spectrum depends on the type of electromagnetic radiation and the nature of matter. The matter can be atoms or molecules with which it interacts. So electromagnetic radiation is a radiant energy that displays the properties of both particles and waves. There are different types of electromagnetic waves that make the electromagnetic spectrum. As you can see in the figure, there are gamma rays, X-rays, UV, visible, infrared, microwave and radio. Gamma rays is the high energy radiations. X-rays is less harmful as compared to gamma rays. UV region or ultraviolet region is where you having when we are talking about sunburn and everything. This is that region. Then visible, that is the electromagnetic radiation that we are able to see. Then comes infrared, microwave, and the last one is radio waves. They are the lowest energy radiations. Electromagnetic radiations have got two components, an electric field and a magnetic field. As you can see in the figure, there is electric field, there is magnetic field, which are right angles to each other. The electric field vector component of the electromagnetic radiation is responsible for the interaction with the matter. And light, when we are considering the light can be considered as a stream of photons and each possessing a discrete quantum of energy, then you can say E is equal to h nu is the equation that we can use, and this energy that we are having is utilized for producing various types of energy transitions in atoms or molecules. So two of the most common interactions are light that is absorbed by the atoms and light that is emitted after interacting with atoms and molecules in the sample. So what is absorption? What is emission? Absorption is a transition from a lower level to a higher level with the transfer of energy from the radiation field to an absorber or atom or molecule or a solid. So this is absorption. And that emission is a transition from a higher level to a lower level with the transfer of energy from the emitter to the radiation field. So if no radiation is emitted, the transition from higher to lower energy level is also called non-radiative decay. So molecular spectroscopy is the study of interaction of electromagnetic radiation with any molecular system. So molecular spectroscopy is the key to this molecular spectroscopy is that a given molecule will specifically absorb only those wavelengths which have got energies that corresponds to the energy difference of transition that is occurring. So consider this case where you have A ground state and B excited state. So if the transition involves the molecule jumping from this ground state to excited state B, with an energy difference of delta E, the molecule will specifically absorb radiation with the wavelength that corresponds to delta E, while allowing other wavelengths to pass through unabsorbed. So that is the key principle in molecular spectroscopy. And by observing which wavelength the molecule absorbs and to what extent it absorbs, we can gain information about the nature of the transitions that a molecule is able to undergo and also about the information about its structure. Now coming on to our main topic, UV visible spectroscopy. UV visible spectroscopy is a study of interaction of electromagnetic radiation. Which electromagnetic radiation? UV visible radiation with the different species. So the outline of this course will be origin of the spectrum, interaction of radiations with the different types of absorbing species, characteristics of the spectrum and the instrumentation used for obtaining the spectrum, principle of UV visible spectrometry and as an analytical tool, and also characteristic absorptions in various organic compounds containing pi electrons will be discussed. So that's all about the introduction.